Hello and welcome to physics. This is a brief introduction to physics. In the first video that I made for the physics course, I talked about the science of physics, and mostly I just focused on what it means to do science. But I didn't really talk about the topics that we are going to cover in this physics class. So I want to do this in this short lecture. If you've been a student at Male High School, you may have had a course in chemistry prior to taking this class. Do you remember how we defined chemistry? The short definition is, chemistry is the study of matter and the changes that matter undergoes. If you look in Wikipedia, it defines physics as the natural science that involves the study of matter and its motion through space and time, along with related concepts such as energy and force. Just because it's in Wikipedia or on the internet doesn't make it true. I think this definition is not quite right. In fact, it sounds a lot like the definition of chemistry to me, with its focus on matter. Rather, I think a better definition for physics is it focuses on energy and changes in energy. Now, obviously, there are interactions between matter and energy, so physicists and chemists can study many of the same things, but they usually have a slightly different focus or purpose in their experiments. Chemists focusing on atoms and electrons, whereas physicists focus on how much energy it takes to do chemical reactions. So what is energy? If that's going to be our focus, it seems like that would be a good thing to know. Unfortunately, it's not a very easy question to answer. Energy is what it is. It is a fundamental aspect of our universe. And rather than being able to define exactly what it is, because there's nothing more fundamental that we can use in our definition, physicists usually just define it as what it can do. The official definition of energy is the capacity to perform work. Sometimes people say the ability to do work. In both of those versions of the definition of energy, you hear this term work. So what does this definition mean? We'd have to look at what the term work means. If I ask you to define the term work, how would you do it? Well, you would probably define it in a very different way than a physicist. In physics class, the term work has a very specific meaning. Work is the result of a force moving an object. Again, that's a very simple definition. Work is the result of a force moving an object, but it involves yet other terms, such as the term force. What is a force? Is it what Obi-Wan Kenobi can manipulate? No, we're not talking Star Wars here. We're going to look at what the term force means a little later in the course. If you look at the definition of work, you'll notice that it also involves moving an object. So, we also have to study motion. What does it mean to move? When something moves, it goes from one place to another place. Now, that implies that we have something called a frame of reference. In other words, we've set up some sort of position as being here, some other position as being there, and so motion means that an object goes from here to there. And it goes at a certain speed or a certain velocity. Are those terms interchangeable? That's something we're going to need to look at. If something starts at one spot and ends at another place, we call that displacement. Velocity is the quotient of displacement divided by time. In other words, how much time does it take to go a certain displacement or distance from point A to point B? You can actually set it up as an equation. Velocity equals displacement over time. So let's put all these various terms that we've introduced together into a little flowchart. Physics is the study of energy. Energy is the capacity to do work. Work means a force moves an object at a certain speed over a certain distance in a certain amount of time. So one way to approach the study of any subject is to break it down like this and then start in reverse. In other words, let's start with time and then build on our understanding of time and talk about displacement, velocity, and then motion, and then force, and then work. And finally, we'll build up to studying the concept of energy itself. Let us first consider, what is time? Do you know? On a sheet of paper, I would really like you to write down your idea of what you think time is. And I'm going to give you 2 minutes of time to write your thoughts down. There's no right or wrong answer here. I just want you to verbalize for yourself what you think time is. Let's take 2 minutes. Okay. Now, ideally, what we would do at this point is have a sharing. Turn to the person beside you and you tell them what you think time is and they tell you. And maybe we can have a bigger class discussion. So if there is a teacher leading this video, why don't you pause it for a while and hold a class discussion. Again, I turn to the internet and our trusted source, Wikipedia, and look up the definition of time. It says that time is the indefinite continued progress of existence and events that occur in apparently irreversible succession from the past through the present to the future. Time is a component quantity of various measurements used to sequence events, to compare the duration of events, or intervals between those events, and to quantify rates of change of quantities in material reality. or in the conscious experience. This last statement is very interesting. Time is often referred to as the fourth dimension, along with the three spatial dimensions. So when we think of time and time passing, you might think of things like clocks or the Earth going around the sun, the Earth revolving around its axis, or sun, or rotating around its axis. Those are all good concepts of time, but it doesn't really tell us what it is. And that's because, again, this is a very difficult concept. If you go back to that last statement that Wikipedia made, it said that there are spatial dimensions. That's up, down, back, forth, left, right, X, Y, Z axis. We're used to thinking of those as dimensions. What Wikipedia is suggesting is that you think of time as a fourth dimension. But if you do that, you come up against some differences between time as a dimension and the spatial dimensions. For example, if you move in space, those motions are generally reversible. You can go backwards or forwards, up and down. Go forward 2 steps, walk backward 2 steps. Time seems to be irreversible. We only move forward in time. At least that's one way of looking at it. However, if you observe events using light or sound, then effectively you are observing backwards in time. It took time for that light or sound to get to you. So if you look at the sun, for example, you're actually seeing what the sun looked like 8 minutes ago, because it took a while for that light to get from the sun to the earth, to your eyes. Interestingly, though we can move forward in time, we cannot see forward in time. We cannot see the future. We don't know what anything's going to look like 8 minutes from now. So the bottom line is, time is a fundamental concept in physics, but we aren't going to get a very good definition to what is time in this course. It's way above our grade level. Instead, we're going to stick with that middle part of the Wikipedia definition and say time is a factor that we can measure. It's a quantity that we're going to measure in units called seconds. If we can, we will come back and explore the nature of time later in the course. If you look on our map, our flow chart of the study of physics, we just covered what is time. The next step seems to be to talk about displacement or distance. That would be a good jumping off point, but in fact, if we follow the textbook, it starts talking about something called mechanical equilibrium, which means things are not moving. So I'm going to follow the textbook sequence, and therefore in the next video, we will talk about mechanical equilibrium, how things stay in place rather than how things move.